This is going to be a demonstration of electromagnetic induction, and for this demonstration I'm going to use this coil of wire. It's a coil of thin gauge enamel coated wire wrapped around a plastic bobbin. It was actually part of a transformer assembly. So normally this would be one winding of a multi-winding transformer, but it was taken from the assembly line before it was turned into a complete transformer. Soldered onto this we have a light emitting diode. Now, like all diodes, these are unidirectional or polarized devices. They only pass current in one direction, and when it passes current in the preferred direction, you will get some light coming out of the diode. So what's going to happen is I'm going to take this stack of magnets here and pass it through the center of this bobbin, and we'll see what the light does. Now you'll notice that one end of the magnet is labeled north and the other end labeled south. I've used a compass to identify which is the north and south ends. And watch what happens when I take this magnet and I insert it into the coil. You notice when I did so, we got a blink of red light there. If I withdraw the magnet, nothing. If I insert, we get light. Withdraw, nothing. Insert, we get light. And that's the north pole end of that magnet. If I turn around and use the south pole, insert, nothing. Withdraw, we get a blink. Insert, withdraw. So what we're seeing is a change of polarity with regard to direction, depending on which end of the magnet I've inserted through the coil. So again, north end, I'm getting a blink as I insert, but nothing when I pull out. South end, getting nothing when I insert, and a blink when I pull out. So it's literally changing the polarity of the induced voltage as I move this. Now, like all examples of electromagnetic induction, there's no induction that takes place when there's no motion. So if I just set the magnet in here and let it rest, it doesn't matter which pole I insert in there, I get no induction. There has to be relative motion. You'll also notice when I did this very slowly, we didn't see any light. So if I do it slowly enough, the rate of the magnetic field flux change in the coil is so low that the induced voltage is not enough to overcome the forward voltage drop of the LED and make it light up. So I have to achieve some minimum speed with this in order to get any discernible light. There we go. So if I withdraw quickly, I get a blink of light. If I withdraw slowly, I don't. And again, that's due to the forward voltage requirement of the LED. You have to exceed a certain amount of voltage at all to get current to pass through it. And the other direction, inserting slowly, nothing. Inserting quickly, I get a blink of light. So, quick, easy demonstration of electromagnetic induction.